Hello everyone, welcome back to the Morning Rant, the show in which I, Alex Racuglia, talk about my life as a TV commercial director and software developer. Today's episode is about algorithms, database and machine learning. So if you're not interested, please just like this video and comment below, I don't like this video, or please talk about something else, or everything you want, but just interact with this video. Increase the engaging so I will be a very powerful YouTuber forever and ever and ever. Amen. Okay, something like a week ago, a potential customer watched about one of these videos about this Content AI, my upcoming app, and said, I'm very interested in this app, but do you plan to add this feature? And he said, when you do a search and you click one of the media, can you please add something like a search similar with content? This is a very challenging task and request. And so I asked to myself, what does it mean to do search for something similar? What does similar means? You know, you can drag something like an image to Google search and say, search for something similar to this. And Google does this in a very optimized way. But the Google is a super, hyper, mega giant, and I'm a very small and poor developer. How can I do something like this? And so I asked to myself, what does similar means? And maybe you can say, oh, Alex, you're a very super talented developer using a lot of machine learning stuff. Use artificial intelligence. This is at the same time smart and dumb. Yes, you can do artificial intelligence, and there are a lot of models that can help me doing this, at least for images, but they are resource and energy consuming. Let's not focus on energy, but focus on resources and time. The first machine learning model I ever used in one of my apps is in the app FCP Postcutter. FCP Postcutter is just an app that tries to find the cuts in the video and to export this segmented video to Final Cut Pro. It's quite powerful. It had a lot of success because it uses two algorithms to find the difference between two consecutive frames, to understand, to know if there are enough difference to mark them as not consecutive, and so to identify a gap between two frames as a cut. First, they try to analyze the colors of the images. They downsample the image to something like 5 by 3 pixels with all the colors, and then compare these 5 by 3 pixels, these 15 colors, this array of 15 colors, to understand if there's enough difference between them. If there's enough difference, okay, they declare there's a cut. But if they're similar, a model provided by Apple that analyzes two images and give you back a threshold, a percentage value from 0 to 100% or 0 to 1 in double precision, that tries to measure the difference between two frames. I actually don't know how this index is created. It has been provided by Apple to understand if there's a group of picture, if all these pictures are taken at the same time in the same location. You know, you shoot 2 or 3 times, maybe a selfie or a group photo. You shoot 3, 4, 5 times to decide later which one is the best. And so this feature, this model has been created to understand if there's enough similarity between two frames, two images, to decide with a certain amount of confidence that two images took at the same place and time. If there's enough difference, maybe there's a cut between two frames, two consecutive frames. And then you can say, okay, you can use this artificial intelligence model, this machine learning model, to find the difference between that particular photo to all the photos in your archive. Let's be conservative. And you have something like 10,000 photos, and it's a very conservative number because many of you will have something like 100,000 photos. We took tons of pictures with our phones. And this model with a modern computer can take something like 0.2 seconds to perform this index. And so if you want to compare a single photo with 10,000 photos, this task can take something like 2,000 seconds, something like 35 or 40 minutes. I don't think you can handle waiting 40 minutes to search something. You want this almost immediately. You want to wait a few seconds, not many minutes. So this way, that will be the perfect one, the ideal one, is not feasible. You can do this kind of stuff using supercomputers and superpowers, but even in this case, there are a lot of stuff that can be done in a different way. And so I say to myself, what does the similar content mean? And so I say to myself, okay, let's do a photo search, such as this one. If I want to find similar content, I have to think about the content. And so I already use an image classification model to try to identify what's in the image, okay? This classification model is based on something like ResNet or MobileNet and something like Net. And it has more than 1,000 categories. So if you take an image and put this in this model will return you something like 1.1 thousand categories. And for each categories, a percentage, a threshold that says, I think that in this image, there's this content, there's this subject with certain amount of confidence, okay? It means that if you take a photo of a dog or a cat or a bird and you put these images in this model, the model will not answer you, this is a picture of a dog, or this is a picture of a cat, or this is a picture of a bird. For each category, the model will report to you something like, I think that in this image, there's a dog with 85% confidence, a cat with 10% confidence, a bird 1% confidence for the picture of the dog. For the picture of the cat, something like 80% confidence cat, 20% confidence dog, 0% confidence bird. And for the bird, 70% confidence for the bird, 10% confidence for the dog, and 5% confidence for the cat. For all the categories, there's a confidence threshold. It means that there's a common part of this neural network that tries to understand what's in the image using a lot of filters, convolution network filters and something like this. I will not explain to you because I don't even understand it. But in the end, it's like that we have 1,000 neural networks. Each network brings us a floating point value, something like a percentage of confidence, that says for each category, this is the value of how much confidence the neural network model put in this decision. Okay? And so the total percentage is more than 100 because there's no correlation between every single last node of this network as a value that can be interpreted as a confidence value of the subject of the picture. I put a threshold of 50% for all these categories, and all the categories that are above 50% in this particular model, in this application, this content AI, are put in the classification. So I don't have an array of 1,000 values, each one with this confidence value. I have just the classification that are above this 15% threshold. If you look at this picture, if you look down in the right corner of this interface, you can see the classification categories that are above this 15%. And this is a not so precise description of what's the content of the photo. This model cannot be used to identify single people. You cannot use this model to identify Alex Racuglia or your wife or your boss or your son or whatever, because it has been not trained to classify this kind of subject. But this model has been trained to classify these 1,000 categories. Looking at these categories that tries to explain in some way what's inside the photo, I can say, you know what? I can use these categories, these strings of categories, to do similar search. If you click on the find similar content on a single photo, a new search has been performed using the same dominant colors of this source photo, and all these tags is made with an AND operator. So for the colors, the operator is OR, but for the content, all the tags are searched, and the result must be something that in the tags has all the tags. So if a photo has 3 tags, let's say a plant, a tree, and a flower, all the photos that has all the 3 categories above 15% will be found. This is not ideal, I know that, but it works. The ideal algorithm should do a search in a multidimensional space. If you have an array of 1,000 categories, each one with a percentage value, you have an array with 1,000 dimensions. We live in a 3-dimensional world. Imagine a world with 1,000 dimensions. You cannot imagine, I know that. And then if you have this kind of a vector, you can perform a similar search using machine learning to find the most similar ones. In a very loose way, this is the way Shazam works. You ask to Siri, what's this song? Siri uses Shazam to do this search, and then it finds the pattern. The pattern is found finding the dominant frequency for each instant of time, and comparing it to a very super huge, large database of millions of songs. The most important thing is that each song is analyzed before, and so the pattern, the frequency evolution pattern of this song is done once and stored in a very super huge and complex database. All this supercomputer can do this kind of machine learning and similarity analysis using a fixed number of songs. But in this case, I cannot do this because each one of you will have a different set of photos. Each one has his own photos, and I cannot train a machine learning model with your photos. I could do this, but it should take so much time and so much computational energy. And each time a new photo is added to this database, this pattern must be added, and this content AI will be much more precise, but using so much energy and resources that it cannot be considered anymore a single user app. Online services can do this using computational power. You cannot do this with your own computer. So this is ideal, but it's not feasible. Okay, I talked too much today. Sorry if I brought you a lot of informations, maybe useless. I don't know, I don't care, because I like to talk about my life as a TV commercial director and software developer while I telecommute from my home to the office. I'm quite happy because now it's spring and there's a lot of light, a lot of sunlight. The sky is blue and the flowers are blooming. A new day in the office waits for me. Thanks for watching me. If you like this kind of content, please like this content, like this video, okay? And if you very like this video, or if you have other questions about these algorithms and this way of doing stuff, please comment below and I will answer you directly or in another video. If you think that I am a very cool developer, subscribe to this channel and click on the bell. If you don't do this, no problem. My main business is selling app, not selling myself in a YouTube channel. And as always, I salute you with my final word. 3, 2, 1, ciao!